There are more than 500,000 detectable earthquakes around the world each year. That's according to the U.S. Geological Survey. Despite how common they are, there's still a lot scientists don't yet understand about the impact of earthquake shockwaves. But there are some big projects going on that are going to hope to change that. Meteorologist Heather Waldman joins us with this week's Forecasting Our Future story. And Heather, how are researchers working on all of this?
Well, Andrea, one of the simplest ways to better understand a phenomenon is to closely observe it occurring. But when it comes to earthquakes, easier said than done is an understatement. So now scientists with Lawrence Berkeley National Laboratory and the University of Nevada, Reno are using a special setup to simulate an earthquake. It's called the Soilbox Project. Dr. David McCallum is a lead scientist on the project, which is one of two major studies that will be combined in a way that was previously impossible.
So the first part of the project, the Soilbox, is to be able to create earthquakes in the laboratory and learn about the phenomena and also challenge our numerical models that we create about phenomena. So we model that on a computer, and we want to see and confront that computer model with data and see how well we do, and where we don't do well, improve those models.
This is an example of what those computer models can produce. It's a simulation of a 7.0 magnitude earthquake along the Hayward Fault in the Bay Area. It's produced using some incredibly powerful hardware, one of the fastest machines in existence. McCallum says this would be impossible without a computer of this caliber. That's because just like in weather modeling, earthquake modeling is incredibly complex, and any single fault line rupture can produce an infinite combination of impacts for us here on the surface. McCallum says the goal of the Soilbox and modeling projects is to figure out the most likely impacts for vulnerable cities and then share those findings.
What we want to do is do these simulations, for example, in the Bay Area, and make those publicly available so that researchers and practitioners all can get and utilize those motions.
Now, to be clear, these models predict the outcomes of different earthquake scenarios, not when and where an earthquake may actually occur. I did ask McCallum about the possibility of predicting the next quake in Northern California. He says our understanding of long-term cycles allows us to predict whether or not a quake is likely on a certain fault, but pinpointing a specific day and time just isn't possible. Back to you.